Swayam Prabha. Digital India. Educated India.
Stratified random samples. What is stratified random samples? A pictorial representation is given on the right hand side. In stratified sampling, the population is divided into strata, that is subpopulation, of similar units. A strata is defined by some common characteristics as gender, income level, age, region, or maybe items for a meal A, items from meal B, items from meal C, or fabrics from a particular type of looms and similar fabric from another set of looms. So in different way that could be strata. Also it could be on the basis of gender, income level, age, region. Also this could be possible when I am going to test certain liking, disliking about the suppose color or a design of a garment. Suppose we want to find out how this particular design is liked by the people. So we can divide the people in terms of the gender. That what is how male people or male like this, how female like this. Or we can divide the population, that is our customers, in terms of their income level. Those who are earning very high, those who are earning middle income group, and we can also have people with lower income group. Or we can divide the population in terms of age also, below 20, 22, 30, 32, 40, like that. Sometimes when you want to find out the customer's choice about color, about design, then we can divide the population in terms of gender, income level, age, region. This is what can be done. So that is what has been shown in the diagram also, that we can see the diagram, this colored dots are there, that three different colors, white, orange and blue, and this is a kind of population. Now we can divide them into strata of white, orange and blue separately. So when the selection comes, we have to make sure that we select our sample from each of those strata. If I directly go for random sampling from the population, there may be possibilities could be there that we only select the whites and don't select the blue ones, or we can only select the orange and blue but not the white ones. These are all things are possible if we go for random sampling directly on the population. So to avoid that, since we need to get informations from different strata, we divide the population into different strata and then take a representative sample from each strata. So from each strata we have taken a sample of some white strata, white, then from orange groups we have taken orange also, from the blue groups also we have chosen the blue, and so there. Now if these are my samples, then this sample is representing the population properly, and there are representations from all different strata. So this is what is known as stratified random sampling techniques. So procedure is, first of all, identify the strata. We have to divide the population into non-overlapping groups based on specific characteristics such as age, gender, income level, etc. That's what we have already discussed, and these are very useful when we want to find out the taste of people, especially customers. So when the customers satisfaction is there or not, then this kind of sampling techniques is going to be helpful. We can, as I said earlier, that gender wise or income wise or region wise also we can divide our populations. Determine the sample size. We have to decide the number of items to be sampled from each stratum. How many I should choose from? Should we choose the same number from each stratum, or should we choose different numbers? So there are two ways. One is proportionate, where the sample size from each stratum is proportional to its size of the population. This is one thing that we can do. Or equal, where each stratum is sampled equally regardless of its size. These are the two different ways. Obviously, the first one is proportionate selection is always better. Then random sampling within strata. Choose an item in each strata by random sampling. And once you have decided that I will choose so many from strata 1, so many from strata 2, so many from strata 3. Now while choosing that many numbers from a specific strata, the selection will be based on random selection technique. For that, it ensures equal chance of selection of a member, or member means in this case an item or a person from a stratum being included in this sample. Combine the samples from all strata to form the final stratified random samples. So this is what the procedure that we follow. When this stratified sampling is used, when the population is heterogeneous. When population is heterogeneous, we can go for when the population is diverse in nature and consists of distinct subgroups with different characteristics. Stratified sampling can ensure adequate representations of each subgroup. Example, customer can be stratified according to income level, which we have already discussed, in order to study their choice of color. So this also can be done, that is, whether the income of a person decides the choice of color. That's whether he likes pastel color, or people like deep color, or any particular color, or people like some colors which we produce by blending or mixing different kind of dyes together. So income level wise, there could be variation in the liking of color, design. Possibilities are always there. And other thing is comparative studies. When making comparison of characteristics between different subgroups within a population, it allows for more accurate and reliable comparison between these groups. So group-wise differences, whether it exists or not, that can be then studied, or that will be reflected in the result. Example, comparing the effectiveness of new process for improving fastness of a dye across fabrics made from different yarns. From different fibers or blend percentage of the components. So in these cases, if we have improved process, so we want to show that the process is equally good for fabrics made from different fibers or fabrics made from yarns which are having different blend percentage or not. So such kind of comparison is sometimes required. Or also you can compare in the case of marketing the liking or disliking of people in the 4 different zones of the country. I can divide the country in 4 different zones and then try to find out. We can divide the country into urban area and rural area and try to find out whether customer tastes are different in the 2 urban areas and rural areas. So such kind of comparison if we want to make, then this is when it is required. Stratifying by type of fabric ensures that each type is adequately represented in the sample. So stratification therefore is sometimes required and sometimes it will give you beneficial results. We will be able to get more informations. There is an example here. Let us say a company arranged training program for its employees and wants to evaluate the training performance of 70 employees coming from different factory locations. Each factory has a different number of employees who received the training. So 5 different locations the people are coming, and obviously the number of people coming from different factories are different in number. How the stratification can be done? For this, the factory locations are stated as A, B, C, D, E. 5 locations are there, and from number of employees receiving training, from A is 50, B is 30, C is 40, D is 20, and E is 60. Total 200. That is 200 becomes my population size. In this case, they have been grouped or stratified according to the factory from which they are coming. So now when we go to find out the sample size, because we want to only find out, we cannot really take information for all 200, but we have suppose decided that we will take information from 70 employees, those who took training. So these 70, how we'll distribute them in different factories. That is, how many of them should be chosen from factory A, factory B, factory C, factory D, factory E. So for proportional representation will be best in this case. So how many will choose from factory A? We'll choose 50. Total is 200. 50 by 200, and we have to total. We have to get 70. We multiply it by 70. We get a figure 17.5. We choose an integer number. So we choose 17 from factory A. So though there are 50 people who took training from A, 17 will be taken to check how was the training performance. From factory B, we'll choose how many? 30 by 200 into 70. 11.5, we make it 11. Similarly, we'll go for find out the corresponding values for factory C, D, and E, and these are the figures. And if we sum them up, this gives me 70, which is the pre-decided sample size. So these are the numbers that we are getting. Now, while choosing 17 people out of 50, we can now use our random numbers to find out which 17 out of 50 you will choose. So that random sampling technique now can be applied to choose 17 out of 50, 11 out of 30, or 14 out of 14. Which 14 out of 40? Okay. From there, we go to what is known as cluster sampling. Here the population is subdivided into groups of units in such a way that it is convenient to randomly sample the cluster and then randomly sample or completely enumerate all the observation in each of the sampled cluster. So there is some similarity between cluster sampling and the previous one that we discussed, stratified sampling. It is useful when cluster represents lots of products or geographical locations. Cluster could be countries, could be district, could be sales territories, like that. When to use cluster sampling? Widely dispersed population. When the population is spread across large geographical areas, group based on sampling method simplifies data collection by focusing on specific region or clusters. Like India is a vast country, so taste of the people will vary from northeast side to the western part of the country, or from northern part of the country to the southern part of the country. Or if it is different continent could be there also, which is also possible. Then we have to go for such kind of sampling plan, that is cluster sampling plan. Natural groupings. Cluster sampling can be effective approach if the population naturally forms clusters, such as household in neighborhoods or students in school. Naturally they form a cluster. School A, school B, school C, school D. So they become small clusters. Limited resources. When time, budget, or personnel are constrained, cluster sampling offers a practical solution by concentrating efforts on selected clusters only. And when the population is very, very large, for extensive population, sampling within clusters enables obtaining a representative sample while minimizing logistical challenges. So if population size is large, then we also would prefer to go for sampling within the clusters. So we'll identify the clusters and then we choose our samples from the cluster. So these are the different situations when we have to go for cluster sampling. The difference between the sampling methods. So these are the 4 different sampling techniques we have discussed. Now we will just discuss the differences between them so that it becomes clear in your mind, and a figure, representative figure, is also given on the right hand side. First is random sampling. We have discussed individual items are randomly chosen from the entire population. So we don't make any subgroups. There is no grouping at all. So like what is shown in this quarter. So you select the items randomly by using the random number table. So here, like, all those tick marks indicate the selections. So here you see that we have selected these people. Whatever tick marks are there, they have been selected. So this selection is simply a random selection. Even though you see that the population, there are 2 different colors indicating that the population is a mixed populations. There may be, let us say, boys and girls. So is mixed. So there is no differentiation. We consider them as one homogeneous unit and select a person randomly. Second is systematic sampling. Samples are selected at regular intervals after an initial random start. So here you see First we start, random start we make from here. And then at regular interval, we are choosing the person. So from there, we skip 2 and go there and select this. Again, we skip 2 and reach here. So we're skipping 2 persons and choosing whoever is there on the third locations. So the first selection is random. The subsequent selections are automatically decided because it is at interval of fixed number. Stratified sampling involves randomly selecting samples within a specific subgroups or categories. Within a specific subgroups or categories. So in a specific subgroup or category, so if I have, these are 2 stratified samples. So green one side and blue on the other side. From the green side, we choose, suppose we choose 2 persons, we are choosing them at random. From the blue groups, we also choose 3 in this case because proportionally, suppose it is 3, we choose 3 also at random. So that is how the stratified sampling is done. And the next we'll go to the cluster, which is this one. The basic difference between stratified and cluster sampling lies in the approach to grouping and sampling. In stratified sampling, samples are chosen randomly within distinct subgroups. As I have told you, these are the subgroups, and we are choosing the people randomly. If we can make subgroups within green, I have suppose made 2 subgroups. This is one subgroup, and this is another subgroup. So from each subgroup, we choose the people randomly. Or we can say that this is basically just 2 groups are there, and we choose the people randomly from each subgroup. So this is only 2 subgroups are here. In the cluster, clusters are selected randomly from the population, and then the sampling all members within each chosen cluster. Say here we have made the clusters. So clusters are like, this is a cluster, this is another cluster, this cluster. So I have 1, 2, 3, 4, 5 different clusters. And now we choose the cluster randomly. So we have chosen cluster in this case. This is the cluster we have chosen, and this is the cluster we have chosen. So these 2 clusters we have chosen randomly. Once we have chosen the cluster randomly, from this cluster, all the items are chosen. Then we do not go for further selections. Whoever are the member of that particular cluster, all of them will be chosen, and necessary test will be performed. So this is what the cluster sampling means. So here all members are chosen. Okay, so these are the basic differences between the 4 different techniques of sampling. Now comes an example. A towel manufacturing company wanted to assess the impact of its advertisement campaign on the satisfaction of customers across the globe. What would be the multi-stage cluster sampling approach? So there are, like India is exporting a lot of towel to different countries. It's exporting towel to European countries, to America to Canada and to other countries also, maybe to Hong Kong also. So different places, geographical locations across the globe, the towels are going. So target population is all those who made the purchase, that is from all those countries. So cluster is to be defined on the basis of the countries. Procedure is randomly select 10 countries from the global operations. Within each country, randomly choose 5 states or province or regions. Then from each state or region, randomly select 10 cities or town. Now randomly sample 100 active users from each selected city or town. Here we cannot really take all the users because that number is huge. We will not be able to do it. So in the last stage also, we have to randomly sample 100 users from that particular city or that particular town and get information about them from them, collect information, whatever we want to find out from those customers in terms of maybe satisfaction, and then we collect those data and then analyze it. Now, the way sampling is done in the case of yarn sampling, we are discussing here. If the consignment contains less than 5 cases, 10 packages are selected at random from all the cases with approximately equal number from each case. So if there are 3 cases, for the first case we choose 10, second case 10, third case 10, total we choose 30 and then we go for testing. If the containment is more than 5 cases, then suppose number of cases is 10, that is cases mean boxes which contains the packages. First select 5 cases at random out of 10. Select 5 packages at random from each of these cases. So total packages selected will be 5 into 5, that will be 25. This is how we can do the sampling of the yarns. In actual case, here is a table which gives you the lot size, which says number of cases to be chosen. Depending upon lot size, how many cases are to be chosen. So there is another example which has been taken from the BIS handbook. The reference is given here. A consignment of 30 cases of cotton yarn of 40 NE has been received by a buyer. The buyer wants to ascertain the conformity of the lot. So the buyer decided to buy 40 NE yarn and the consignment has arrived. While 30 cases are there, the buyer has to ascertain, the buyer has to be sure whether he has received 40 NE or not. So how the sampling procedures will be done. So according to the table, if I look at the table, when we have lot size is how many? In this case 26 to 50. So I have to choose as per BIS 8 cases out of 30. So according to the table, the number of cases to be selected for drawing package will be 8. So out of 30, 8 will choose. Choose the 8 cases at random from the lot. First of all, this is what we have to do. Number of tests to be carried out, total is 25. That is, suppose count testing we want to do, so count testing will be done on 25. So hence 25 divided by 8, 3.12 yarn packages to be drawn from each case. So from each case, 8 packages, 8 cases we have chosen. Out of 8 cases, from each case or each boxes, we will remove How many? 3.12 package, which is, obviously decimal figure, we cannot have 3.12, we have to choose 3. So what we will do, but if we choose 3 from 8 packages, it will be total 24 packages. But we have to test 25 yarn samples. So there is one sample is, or one bobbin is less. So what we will do, first choose 3 yarn packages from each case starting from 1st to 7th case. Now choose 4 packages from the 8th case. That will make you total 25, because this 25 is also based on some standards, that how many tests we have to perform. So 3 into 7, that gives you 21, and the last one we choose 4 into 1, that gives you 4. So total we get 25 packages. So we can make 25 testing of the count we can perform. That's what is done. Here we are, as I told you earlier, that is how to, now we say that randomly you have to select, randomly you have to select. Many times I have told you just that you have to select the sample randomly. Now for random selection, what is the process that we follow? So here is a random number table consisting of 2-digit numbers. This table also has been taken from the BIS handbook on textile testing, part 2. This table is given there. So here the numbers that you see in this table, they are all random numbers. So what we'll do, suppose the numeral 03 is occurring in the 4th row and 8th column is chosen at random. So we'll to first keep searching where the single digit numbers are coming. So let us say we first start with this number. This number we can choose arbitrarily. There is no, there may be another number 08 here also, which can come earlier. But suppose we start 03, we can start 08 from here also. It doesn't matter. We choose any particular numeral, and now from there proceed further in any direction. I can go in any direction, right or left. I can go this way, or I can go this direction also. Now suppose I go on the right hand side directions and enumerating the numerals which are not greater than 25, because we are to select finally 25, in this case bobbins. So if number is 25, then we'll go this way, and then we'll find another number which is here, another number which is here, another number we'll find it. If we go this direction, we'll go this 13, and like that we'll go. Now arrange these numbers in ascending order, and the sequence of 1, 3, 10, 11, 13 is obtained. It will continue. So whatever, it is not really connected to the previous example. Just suppose we have to select 25 items at random, and from the population, then and each items is also numbered. Then we can use this table and find out which numbers we have to choose, so that we can follow the random selection procedure. So find out, choose any number, and then go on the right hand side. I can choose, I could have started from here also, 93 also, then I could suppose there are 100 spindles, so I can start with 93 and then keep going on the right hand side till whatever number of bobbins I have to choose, that many bobbins or that many numbers are chosen. So here is this is how the random number tables can be used. In the case of fabrics also, similar procedure is followed, but one important part in fabric selection, specimen, especially fabric specimen selection, is the samples are to be taken from warp and web direction, as properties may differ in both directions. So these are the specimen 1, specimen 2, specimen 3, specimen 4, and this is one fabric suppose roll. And we have to first identify which one is warp direction, what is web direction. This is web directions and this side is warp directions. So web is here and warp is going this direction. So warp direction and web direction should be marked. Now, no two specimens would contain the same set of threads. The way we'll cut the specimens, same set of threads should not repeat on the specimen. Like if I take the specimen 1, then whatever warp threads and web threads are there, if we go to specimen 2, if we cut it here, then warp threads and web threads are different. So 3, 4, like that, if we cut, we'll find in all those specimens, the warp threads and web threads are not same, they are different. Samples should not be taken from within 5 centimeter of the selvage. So this is the selvage. From 5 centimeter from the selvage side, we should not take the specimen. Here samples mean specimen samples, as properties there may be different from the bulk. So this is what we need to follow. So with this, we close this particular discussion on sampling procedure. You have got a fair idea about the sampling part, though sampling is basically a part of more of testing. But in the case of statistics also, because many times you have to go for sampling and then you have to find out we have to do the test and then we get certain data and then we go for analysis of this data. So sampling is very, very crucial. It should not be biased at all. Otherwise, whatever, if sampling goes wrong, statistics cannot help. Whatever data is provided or generated, based on those data, we do all sort of statistical analysis. So what is very important in statistical analysis is the reliability of the data that we are getting. If the data is coming from test results on certain instruments, the instruments should give me proper readings. The other thing is that during testing process or testing procedure, we must follow or we should take all the precautions so that the results are unbiased. Similarly, the specimen that we choose, the sampling technique that we follow, you should also follow very standard sampling procedures. Then selection of the specimens. Everything should be done properly. Then only the data that we generate, the data will be very, very reliable. And on that data, we do all sort of statistical analysis. And then we can get based on statistical analysis, we can make certain decisions. And those decisions will be will have a very scientific backing. With this, okay, let us close today's discussion. Thank you all. Good luck.